In this statistics lesson, we will be using normal distribution to find values instead of finding probabilities. This time we're going to find values. So please feel free to press pause, read through today's objectives. All right, so in our previous lesson, we've talked about how we were given a normal distribution X and we were asked to find the probability. All right, now we're going to go backwards. We're going to be given the probability. We are going to need to go back and find the Z value that corresponds to that probability, and then we will need to go backwards again and find the random variable X that goes with that probability. That goes with that Z-score. So this will be very much doing everything we did before, but only doing it backwards. So we'll kind of take some small steps here at the beginning and then work our way up to doing a problem completely backwards. All right, so let's start with just finding the Z-score that corresponds to a cumulative area of 0.3632. Okay, so again, if we draw the picture, we are given an area that is less than 0.5. So it's going to be below the Z-score of 0, so it's going to be over here somewhere. So this area is 0.3632. First, we need to find the Z-score that corresponds to that. So that's what we're looking for first. Okay, so this time, again, I'm going to use my chart, but this time I'm going to use my chart a little bit different. I will need to find that probability inside the chart first. So if we look at our charts, we will need to go in the chart body itself and find that probability. Once we have found that probability, we will then find our Z-score from the row and the column that corresponds to it and give us that Z-score of negative 0.35. So if your area is less than 0.5, you're going to be on that negative Z table, and if you have a probability of higher than 0.5, then you're going to be on the positive Z-scores because you are above and below. All right, so I can go back here, and that Z would be negative 0.35. So again, it's going to very much be working backwards. Before you had the Z-score, you went to the inside of the chart to find the probability. This time you're going to start on the inside of the chart with that probability and then work backwards to find the Z-score that goes with it. And if you ever can't find the exact score on there, the exact probability, say the probability is between two probabilities, go with the probability that is the closest to the one you're looking for. Again, that's where technology is going to give you a kind of a heads up, a little heads up, a little bit more accurate answer, but you can still use the charts for those. All right, find the Z-score that has 10.75% of the distribution's area to its right. Okay, so let's draw the picture. We want to the right. So we want this area up here. We want this to be 0.1075. Again, our charts don't tell us the area to the right. They tell us the area to the left. So this area over here is going to be 1 minus 0.1075, which is 0.8925. So we are going to use this area to find the Z-score that goes right there. What is that Z-score that corresponds to that? So go to your chart. This time we have an area above 0.5, so we know we're in the positive Z's. So we go and we look inside the chart to find that 0.8925. And again, let me show you what that looks like. So locate that exact value in the chart and then use that to find your Z-score. So your Z-score should be positive 1.24 when you look in the chart. So again, very important that you know how to use this chart to find your way back and forth. All right, another way they could ask this is ask you for a percentile. So find the Z-score that corresponds to the percentile P sub 5. So the 5th percentile is what they're asking you for. Okay, the 5th percentile means that 5% of the people are below you. So you are here, and this area right here is 0.05. Okay, 5% of the people are below you. So you're definitely going to be in a negative Z-score situation because you are very much below the mean. You're below the center. So I would go to my chart. I'd go look exactly for 0.05. And unfortunately, I'm not going to find it. I'm going to find, when I look at my chart, it says 0.0, hold on, let me make sure I write that correctly. 0.0495, and I have 0.0505. And notice these two, the one I want is directly in between those two. So if you have a situation like this where it's not one or the other, it's not closer to one or the other, take exactly the value in between. So the 0.945, this one has a z-score of negative 1.65, and the 0.0505 has a z-score of negative 1.64. So you're just going to take the z-score, just take the mean of those two scores. So our z that we are going to look for is negative 1.645. And again, you can only do that if you have two values, two probabilities that are exactly as far apart from each other. And there is no one that's closer than the other. If one were closer than the other, you would just choose that. But in this case, neither one of those was closer. So we're just going to take the mean of those, the z-score halfway in between those two. All right, here's another one. Find the z-score that corresponds to the percentile p sub 50, so the 50th percentile. So that means 50% of the people are below you. So right here, here's you, and this right here, this area is 0.500, which means you are the middle. So this one you shouldn't need to look up on that chart at all. That z-score is going to be equal to 0. Right? You are the mean. If 50% of the people are below you, you are the mean. You are the average. So again, no chart required on that one, which is rather nice. But even if you did use the chart, you would still get a value of 0. So that's the good news. All right, find the z-score that corresponds to the percentile, the 90th percentile. So again, if we draw our picture, we want 90% of the people below us. So this area here, we want that area to be 0.9000. So we want to find that z-score that corresponds to that. So I'd go to my chart. This is obviously a positive z-score situation because we're above 50%. And the closest one on the table is not 0.9. We don't have 0.900 exactly. It's 0.8997. That's the closest that we're going to get. So that means my z-score is about, it's not equal to, so my z-score is about 1.28. That's the closest I can get. Again, if you use technology, you can find a more accurate z-score, but it's still very close. In fact, I used Excel to check mine, and when I used Excel, it said it was 1.281551566. So again, but still if I round it to 2 decimal places, which I should be rounding my z-scores to 2 decimal places, I still get 1.28. So I get exactly the same answer as if I use the chart. So you will find that they are very, very comparable, technology and using charts. All right, so once we've done that, once we've used the percentage, used the probability to find our z-score, now we have to go work backwards and take that z-score to find the x value it corresponds to. In order to do that, you will need to use that z-score formula, and this is the z-score formula that's been transposed and solved for x. So notice my z-score is usually z equals x minus the mu over the standard deviation. First thing I would do to both sides is multiply by the standard deviation. So x times sigma equals z times sigma equals x minus mu, and then I'd add mu to both sides to solve for the x. So that is how they got that formula. It is just the z-score formula that has been just transposed and solved for x instead of being solved for z. It's the same thing. So if you just like using the z-score formula, you can do that as well. You do not have to use this formula per se. You can just keep using that z-score formula if you like. Right, so let's do some examples where we have to do this. Okay, so the veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds. Okay, important information, so I'm going to highlight that. We've got a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights x corresponding to each z-score. So they're giving us the z-score for the weight of the cats, and then we need to find the actual weight of the cat. So our first z-score is 1.96. So again, I'm going to start with that formula. X equals mu plus z sigma. Or you can start with the other one. It's entirely up to you. I just like this one for this just because we're looking for the x and it has already solved it for x. So it just makes sense. So I just got to plug in my mean, which is 9, plus my z-score, which is 1.96, and then multiply that by my sigma, which is 2. So I would just toss that all in my calculator, and it would tell me that my X value is 12.92 pounds. So the cat that has a z-score weight of 1.96 will actually weigh 12.92 pounds. All right, definitely higher than the mean, right? Almost 2 standard deviations above the mean. The mean's 9 pounds, so that cat's probably a little overweight and could use a little diet. All right, number 2, what if I have a cat that has a z-score of negative 0.44? It means they're a little under the average weight. So their X value, again, mean plus z times sigma. So mean is 9 plus my z-score, which is negative 0.44, times my sigma, which is 2. I'd plug that all in my calculator, and I would get 8.12 pounds. So this cat is slightly less than the mean, but they're not more than 1 standard deviation below the mean, so they're very normal weight for a cat. A little on the low end, but still a normal weight. All right, and my last one, z is 0. If your z is 0, remember, that means you are the mean. So you are the mean. So any cat that has a z-score of 0 means that they weigh 9 pounds exactly. They are the mean weight for those cats. All right, so again, thinking holistically, like think about the problem as a whole. All right, so let's work completely backwards and see what happens. Okay, so scores for the California Police Officer Standards and Training Test are normally distributed with a mean of 50. All right, that's important. So I'm going to highlight that, mean of 50, and a standard deviation of 10. Okay, an agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible to be hired by this agency? Okay, so if we are in the top 10%, right, normally distributed, we are up here. We want this area to be 0.1000, okay? Which means this area down here is going to be 0.9000, right? Top 10%, bottom 90%. We need to first figure out what that z-score is right there. What is that z-score that corresponds to that? Okay, so I would go to my data chart. I would look up the 0.900, because again, I can't find the area to the right. I can only find the area to the left. So I would look up that 0.90, and we don't have anything that is exactly 0.90. I have a 0.8997 and I have a 0.9015. So I'm going to choose that 0.8997 because that's the closest. So again, the closest I could find for this area is 0.8997, and that has a z-score of 1.28. Okay, so I have a z-score of 1.28 for my top 10%. So I have to have a z-score above 1.28 to be hired by this agency. We know the mean is 50, and we know the standard deviation is 10. So I have all the information I need using that formula, right? X equals mu plus z sigma. I'm just going to plug in all that information. So my mu is 10, my z is 1.28, and my sigma is 10. So I'm going to plug all that in, get that in my calculator, and that means my score is about 62.8. Now, I know that this is a little bit lower than this, so I should definitely round this up. So I need a score of at least 63. So the person who scores a 63 is just barely eligible. They're just barely in the top 10%, and they would be eligible to be hired by this agency. All right, next example. If we identify the birth weight in grams of a male baby is significantly low, so that means they're in the bottom 5%, assuming that males are. Okay, so we need to find that birth weight for a significantly low birth weight, so bottom 5%. Important information, mean of this, standard deviation of this. All right, and we want the bottom 5%. So if we were to draw that, we're going to be way down here, and we want that area to be 0.0500. So then we need to find that z-score right there that corresponds with that. So this is definitely going to be a negative z situation because I'm very much below the mean. And I would look for 0.050 exactly. And if you remember, we just had this in a previous problem where we couldn't find it exactly. So that would give us, we use that z-score of negative 1.645. So there's my z-score for that bottom 5%. I know the mean is 3,272.8 grams, and my standard deviation is 660.2 grams. So I need those three pieces of information to use my formula. X equals sigma plus z time, mean mu plus z times sigma. So I'm going to plug in everything I know. I know my mu is 3272.8. I know my z is negative 1.645. And I know my sigma is 660.2. So I'm going to throw all that in my calculator because I'm definitely not doing that by hand. And I get 2,186.8. So that means if you are below 2,186.8 grams, if you're a male baby when you are born, that means you are significantly low. You are in the bottom 5%. So any baby that weighs less than that, they're probably going to be really concerned about that baby and want to know why it's so low, why its birth weight is so low. There are many, many reasons that could lead up to that, so we'll let the doctors figure that part out. All right, another example. In a randomly selected sample of U.S. adults ages 20 or over, the mean total cholesterol level, okay, mean, so I'm going to highlight that. The mean total cholesterol level is 190 milligrams per deciliter, and a standard deviation of 40.9 milligrams per deciliter. Assume the total cholesterol levels are normally distributed. Find the highest total cholesterol level an adult age 20 or over can have and still be in the bottom 1%. Okay, so there's my thing. Here's my normally distributed curve. I need this to be 0.0100. Okay, what's the z-score that corresponds to that? So let's go to our chart, and we're going to look inside the chart for 0.01. And the closest I can find is 0.0099. So I can't find exactly 0.0099. That's the closest I can find. So the z-score that goes with that is negative 2.33. So I'm going to use this z-score with my mean of 190 and my standard deviation of 40.9 to find the cholesterol level itself. So use your formula. X equals mu plus z times sigma. So my mu is 190, my mean, plus my z-score, which is negative 2.33, times my sigma, which is 40.9. All right, so I'm going to throw all of that in my calculator and press enter, and it's going to tell me that my cholesterol level is 94.7. So that means that 1% of the population has a total cholesterol level of 94.7 or lower, so about 95. So if you have a score of 95 or lower, you have an extremely low cholesterol level, right? You are in the bottom 1%. All right, so one last example. This time we're going to be designing a front door for a home. And when you're designing equipment, again, there's lots of codes, so that's what we're going to be talking about in this. Our design has to accommodate at least 95% of the population. So what is the height of a door that would allow 95% of adults to walk through the doorway without bending or hitting their head? Okay, assume that the height, so again, let's draw that out. So 95%. So we want 95% of our people. So we want this area to be 0.9500. We need to figure out what this X is. How tall is that doorway have to be so that people won't have to bump their heads? Assume that the heights of adults are normally distributed with a mean of 66.2 and a standard deviation of 3.8. So I'll highlight that important information because I'm going to need that. And then we'll answer that second one first. Let's answer this first question before we're looking at that second question. Okay, so I can use that 95% to find my z-score. All right, so I can't find the x directly, so I can use this to find my z. So let's do that first. So I'm going to go to my chart, and inside my chart I'm looking for area of 95%. And again, this one is another situation where it's not exact. There are two values that are equally equidistant from 0.95 in that chart. So that's going to give me a z of 1.645. You're going to have to, it's equally between 1.64 and 1.65. So let's go halfway. And then we're going to use that z-score along with the mean and the standard deviation to find our x value. So our x is going to be, again, using that formula, mu plus z times sigma. So mu is 66.2 plus 2 times 3.8. Oh, wait, not 2. My z-score is not 2. My z-score is 1.645 times sigma, which is 3.8. My z's always look like 2. I should make sure I put a little thing there to make sure. Okay, so I'm going to put all that in my calculator, and I am going to get an x value of 72.451. Okay, so that means that the door height needs to be at least, so door height of at least 72.5 inches, okay, will accommodate 95% of adults who walk through that door. So this will accommodate 95% of adults. All right, now the second part of the question says, how does this result compare to the door height of 80 inches required by the International Residential Code for building? So notice, so this height that we have now is 72.5. Well, their height that is required is 80 inches. So 80 inches would be here. So notice 80 inches is going to cover more than that 95%, right? We're going to have a higher probability if we were to scooch that over just a little bit and include this area right here. So more than 95% of adults would be covered. So if you stick with the residential code, you're definitely going to cover that 95%. And have room to spare, right? You're going to cover more than 95% of adults. So that is how we can use those standard normal distributions to help us solve problems. So come back next time. We'll talk a little bit more about these and how we can use standard deviation, how we can use these standard normal distributions. And we'll see you then.